Hi, this is Pat Schnabel from Data to Bio. I want to share with you the results of a thought experiment, which, if you're involved in next generation sequencing, I think you're going to find interesting. Back in the mid-1980s, I was sequencing using Maxim Gilbert technology. This involved using radioisotope tracers, running acrylamide gels, and then using X-ray film to detect the bands. On a good day, we could get 100 to 200 base pairs per lane. So we were thrilled when Sanger sequencing came along, and then even more thrilled when fluorescent detection and automated Sanger sequencing instruments came on the market. The way this worked is we'd send our DNA fragments over to the facility, they would email back the nucleotide sequence, and we'd go over and physically pick up a hard copy printout of the chromatograph. And we would examine this for quality, and we would keep the hard copy as a backup. Starting about 6 or 7 years ago, we transitioned mostly to next generation sequencing. And these days, we're using mostly the Illumina HiSeq 2000 to generate our sequencing data. This instrument generates about 90 million reads per lane. And if we use paired 100 base pair reads, we get about 18 times 10 to the 9 base pairs from each lane, and it takes about 8 days. The sequencing cost, if we pay list price, is about $6,000. So here's the thought experiment. If we wanted to generate a hard copy backup of the data from one lane of Illumina HiSeq, how much paper would be required? Well, we figure we can fit about 2,500 characters on a single page of paper. If we divide this into the 18 times 10 to the 9 base pairs of data per lane, we need about 7 million pages of paper. Each ream consists of 500 pages, so this is equivalent to 14,400 reams. Each case of paper consists of 10 reams, so our little thought experiment here would require 1,440 cases of paper, which would fill a room 12 feet by 12 feet by 12 feet. Now, so far, all we've done is calculate how much paper is required to back up the data from the Illumina HiSeq. We need to still now get the data onto the paper. So we looked for a printer. We found a fairly fast printer that does 50 pages per minute, and it uses up a disposable cartridge every 24,000 pages. So to move the data from the Illumina HiSeq onto the paper would require 300 cartridges and 100 days. And of course, we have to pay for the paper and the cartridges. Paper, 1,440 cases of paper at $40 a pop, 300 cartridges at $300 each, a grand total of $147,000 to print out the data from one lane of Illumina HiSeq. And remember, we could generate the data for $6,000 list price. So this just illustrates how far we've come when generating the data is substantially less than the cost of printing the data. And interestingly, if we wanted to do this routinely, which only an idiot would want to do, we'd require 12.5 printers running non-stop to keep up with the data flow from the Illumina HiSeq 2000. So we're in an era where there's lots and lots of data being generated. This was the motivation for establishing Data to Bio. We help biologists design and analyze next generation sequencing data. So if this is you, if you're generating such data or thinking about generating such data as part of your project, check out our website, datatobio.com, and then email us if you have questions. We'd be happy to talk to you. Thanks a lot.